solve question 200 number of islands from LeetCode. Let's jump to the question. Giving an m by n 2D binary grid which represent a map of 1 land and 0 for water, return the number of islands. So what is an island? So the definition of island is here. It says an island is surrounded by water, and so when it's surrounded by water, so it means it's surrounded by 0, right? And it's formed by connecting adjacent lands horizontally or vertically. So when it says adjacent lands, it means we are referring to one, so it means that island is surrounded by one horizontally or vertically, right? And you may assume all 4 edges of the grid are surrounded by water. So all 4 edges of the grid, the matrix, are surrounded by water. It means it's surrounded by 0. So considering that, based on this definition, an island, the grid is surrounded by water, so we consider all this area is surrounded by water or 0. And the other thing is when we see an island, they are vertically or horizontally, they are connected, right? They are adjacent. So the number of islands that we have in this example, based on that definition, it's going to be so let's see here, these are all connected, so it's gonna be 1 island. You might say why? Because this one, they are all connected together. As you see, they are connected. If one item is connected to one, even one, as you see here, this one is just connected to one land or one, and we consider it connected to the rest of this island, right? So it doesn't have to be like all the 4 corners, just one corner, like one of the 4 edges. If it is covered adjacent with one, we consider it as a connected island. So let's see if I show it like this. This is how we consider the connection. So if we have one island here, and if we have another one here, these 2 are connected, we consider them as connected. So these are connected. If we have one here, we consider these 3 one as an island, and they are all connected together, right? So they're not like, we don't consider them as 3 separate islands. They are all connected, even with from one side, or like this one, it's connected from 2 sides. It doesn't matter, 1 side, 2 sides, or from all the corners. If it is connected, we consider this as all as 1 island. And what do we consider as a separate island? In this example, as you see, we consider this as 1 island, and this is another island. Why? Because all the 4 corners are connected, all the adjacent corners are 0. And how about this one? We consider this one as another island too. Why? Because 2 corners are 0, and this corner is 1, and all the down here is considered 0 as well. So we have 3 islands here. So let's jump to the code and see how we can solve this problem. So I have used this code from this account, which I think is very neat, clean, and very easy to understand. So we use this code, and the time complexity and space complexity is good. So the way we do it, we start iterating over the grid or this matrix 1 by 1, and we count like islands, and we use a count which starts from 0 for counting the number of islands. And you might say, okay, this way we can find the islands, but we can count like each one in the grid as 1 island. So this way we are going to have 1, 2, 3, 4, 5, 6, 7 islands, and that's not right. And that's the good point. And for avoiding this situation, we are going to use a DFS traverse to find the adjacent node and change them to something other than 1. This way we don't count them repeatedly, and this way we count them only once. And for doing that, what we are going to do, we are going to use 2 for loops, right? We are going a for loop, one for loop inside another one, and we going to iterate over every single item in this grid. And when we hit 1, this is how it triggers the DFS function. And in the DFS function we are going to do something that avoid duplication, which I'm going to explain it to you. So let's start iterating and see how it goes. So I is 0, j is 0, and this is 1. So this triggers the DFS function. The DFS function, what it does, it says it starts with like if I is smaller than 0, which is this area, right? If I is smaller than 0, and if j is smaller than 0, which is this area, and if j is bigger than the length of the grid, and if I is bigger than the length of the grid, which is all this area which we consider as water, or when the grid is not equal to 0, we're gonna return, right? And what we do if they are not 0, if they are not 0, which is, it means it's 1, what we are going to do, we are going to change this to hashtag. And the reason is we are going this way to avoid duplication. If next time we get to this point by this recursive call of the DFS function, and this is not 1, so we don't count this again over and over, right? So, and then what we are going to do, we are going to call the DFS function recursively for the surrounding the plus surrounding items in the grid. So we are going to call it for this one, for this one, for this one, and for this item, right? And what it does, it calls the DFS function recursively, and if it has this condition, it's gonna return, and if it is equal to 1, it's gonna change that 1 to hashtag. And this way we keep recalling the DFS function to find all the 1 and change them to hashtag. And this way we don't count an island recursively. As you see here, for the DFS grade 0, 0, this is what we get. So it's changed the 1 and 0 to hashtag, and 0 and 1 to hashtag, and we have already changed the 0 and 0 to hashtag. And then for an 1 and 1 we are going to change it to hashtag. And for the cases that we have the same indices again, like this one, 0 and 1, because it's not 1 anymore, so it's gonna just return. And this is how we solve this problem. I hope you got a better understanding of this question and the solution. The time complexity for this case, it's m by n, which is the m is the number of rows and n is the number of columns, because we are iterating over every single items in the grid. And the space complexity is at worst case n by n, and the worst case is if we have like all the items here are equal to 1, and because we are calling this recursively, so we are using stack. Thank you.